You found them out for my other one. I put it on book opening.
We're going to talk about finding trig functions of any angle today. So it's really no different than what we did last week. It's just that you've got to be able to draw the picture that goes with the information you're given. Okay, Riley? All right, so we're going to evaluate trig functions at any angle. And then we're going to talk about these quadrantal angles. And then tomorrow we'll use reference angles to evaluate trig functions. All right, so we'll do 1 and 2 today, basically. So it says let P represent the point XY, except the origin, on the terminal side of an angle in standard position. So last week we talked, when we got into the angles again, we just talked about how to put it in standard position. If my head is the origin, this is the positive x-axis, right? And then we called that the initial side, and then we moved the terminal side around and stopped our angle wherever, right? So that's what they're saying. They're just moving it around. They said let R be the distance from the origin to the point. Okay, that's going to end up being our hypotenuse. And then the 6 trig functions for theta are these. So the sine of theta is y over r. Well, it's still opposite over hypotenuse. Okay, the y number, once you draw your picture, the y value will be the opposite side from theta. Cosine of theta is x over r. X will still be the adjacent side, just like last week. Okay, that x value from your point ends up being the length of the adjacent side. And again, r is our hypotenuse, and r is always going to be a positive number. The x and the y might be negative this week. That's okay, but the r, the hypotenuse, will always be positive. Tangent is still opposite over adjacent. The y value will be the opposite side, and the x value is the adjacent side. And then cosecant, secant, and cotangent, again, are just the reciprocals, just like last week. And again, the way we find the hypotenuse is just like we did last week. Okay? We still do a squared plus b squared equals c squared. Well, a is the x, and b is the y, and then r is the c. So it's the same stuff. It's just they're using different letters to do that. Okay? Now, I might as well tell you this now. When we think of sine and cosine, if we are putting them in alphabetical order, which one would come first? Cosine, right? And when we think about x and y, which one would come first in the alphabet? X, right? So some people have trouble remembering if it's x over r for cosine or y over r, So just think about the alphabet. Cosine comes first in the alphabet. X comes first in the alphabet between x and y and cosine and sine. All right, so the y goes with the sine, the x goes with the cosine. Okay? Tangent is always y over x. Okay, think about slope. Slope formula was always the y's in the top and the x's in the bottom, right? If you want to remember tangent. Okay, so here's a picture of what I'm talking about. All right, we got our x and our y axis. We got our point over here in the second quadrant. Okay, so this angle, whatever it is, it might be 120 degrees or something. All right. The theta that we're going to use is going to be inside the triangle we draw. We're going to draw a vertical line from the point to the x-axis for our right angle. And then we draw a line, we'll draw a line back to the origin. And that blue triangle there is our right triangle we're looking at. Here's theta. Theta will always be back by the origin, not up here by the point. Theta will always be down here inside our triangle. Okay, that's our point of reference. So as you can see, if theta's here, the y is still the opposite side. The x is still the adjacent side. And the r is still, or will be, the hypotenuse. Okay, so you still, once you get your picture drawn, and you put theta back here by the origin, no matter what quadrant you're in, it's always back here by the origin inside the triangle. You'll still know opposite, adjacent, hypotenuse. But it will always be, the opposite side will always be the y value of the point. And the adjacent side will always be the x value of the point. Okay? And remember, our quadrants are first, second, third, and fourth quadrant. You guys should remember that. Things not clicking very good. Right? So looking at an example, we're going to give us one in the second quadrant again. So the point we have is negative 4, 3 that you're given. So this is what the type of problem you'll get. They'll give you a point, and it says find the 6 trig functions, the 6 trig ratios. Okay? So you draw a line from the point back to the origin. You draw a line straight down to the x-axis to make your right angle, and then from there go back to the origin. All right, theta will always be back to there. That's our point of reference. So this distance is a negative 4, that length of that side, and this side is positive 3. So to find the hypotenuse, I'm going to do just like I did last week. One side squared plus the other side squared equals the hypotenuse. In this case, they call it R. Right? So we got 9 plus negative 4 squared is still a positive 16. So you're always going to get a positive number here. And remember, you have to take the square root. Some of you didn't realize the square root of 25 was 5 on Friday. Overall, you guys did really well, but whichever form you're in, one of the forms, you got 25, and some of you left it 25, some of you left it the square root of 25. Well, you should simplify. The square root of 25 is 5. So,
I thought it was a negative 25.
why? Why do you think it's negative?
No, on Friday I had negative 25.
Yeah, but it's still, no matter what, I think what you did, if I remember right, is you had the 4 over here, I think, and the 4 should have been on this side, not that side, I think. All right, and then we just do what we did last week. Sine, cosine, tangent, cosecant, secant, cotangent. Again, sine is opposite 3 over hypotenuse, which we said was 5, right? And then it's reciprocal, it's cosecant theta, so 5 over 3. The cosine is adjacent, negative 4 over hypotenuse 5. And secant, reciprocal, 5 over negative 4. And then tangent, TOA, opposite over adjacent, y over x. And then cotangent, adjacent over opposite. So you will get some negative answers, that's okay. Last week we didn't get any, this week we will. Okay, so the only information you're given is that point. And from that point, we should be able to find the six trig ratios, six trig functions. You draw your right triangle in from that point. Any questions? Okay, so here's another point, -3, -2. Again, it says find the exact value. So I want it in fraction radical form. I do not want any decimal answers. And I told you that on Thursday, right? Some of you gave me decimal answers. You did get full credit then, even though your decimal might have been correct. All right? So, what quadrant is this point? Third, very good. And it's going to be really small, but I would come over here 3 and down 2. There's the point, right? So to draw my triangle, I always go back to the origin and vertically to the X and then back over there. So it's always, the right angle is always on the X-axis. Okay, theta is always back here, where that blue dot is. All right, so I'm going to blow it up so it's not so small. The X value is -3, the Y value is -2. Again, theta is back here by the origin. Here's our Y and our X axis. Okay, that makes sense? So what's -2 squared? +4. And what's -3 squared? 9. So that's 13. So what's R? Square root of 13. And again, that's always positive. Okay, right, Brookie? And then from here, we just do SOHCAHTOA again, right? So, Zoe, what's sine of theta? Right, good. Now, am I supposed to leave it like that? No. We talked about that last week too, right? Some of you didn't simplify. You had the right fraction, and you didn't simplify it, so you didn't get, you missed the point. Everything was right, except you had radicals in the denominator, so I gave minus a point. We have to rationalize. Okay? Make sure we do that. So its reciprocal is just take this first fraction. Don't flip the second one. Right, Garrett? Because then you're going to have to rationalize again. If I use this first one, the radical's in the top, -2's in the bottom, I'm done. Okay? So cosine would be what, Drayden? Right, and then when I rationalize it, I get that. So again, the secant is split that original, square root of 13, over -3. Clay, what's tangent? Right, -2 over. So since there's two negatives, I'm just going to make them positive. And then cotangent is just put that. Okay? Does this make sense? So it's just being able to draw the picture. Once you got the picture, it's just like last week. You do have a few negatives. All right, so far so good? So you're gonna have like 3 or 4 of those for homework. Like that, okay? The other thing we're talking about today is quadrantal angles. Okay, quadrantal angle is an angle whose terminal sides coincides with the x to the y axis. So here's my initial side. I start going up and it stops right there. So it's right there on the y. Okay, we call that a quadrantal angle. All right. How many degrees would that be from here to here? 90. So 90 degrees is a quadrantal angle. And in radians, that's pi over 2. Okay? Over here is how many degrees if you start there and stop here. How many? Somebody? Anybody? You don't have to whisper it. Thank you. Which is pi in radians. Okay? If I start here and stop here, how many? 3 90s. What's 3 9s? Yeah, 27, so 90s would be 270. That's 3 pi over 2 in radians. And 1 complete revolution, you guys all know, is how many degrees? 360, right? So if you had 0 or 360, you're at the same spot, which is 2 pi radians. So those are the ones that you really can't draw a picture of a triangle when you're on one of those axes. Okay, so now you're going to have to think about which one's x, which one's y, and which one's r. Okay? And think about alphabetical order, right? Cosine went with which one, x or y? X. Sine went with y. Okay, r is always hypotenuse. Always from the origin to the point is the r value. Okay, so it says values of the trig functions at quadrantal angles. So they said at 0 degrees. All right, so 0 degrees is right here. It doesn't move. It started and stopped there. 360 is the same thing. So you can pick any spot on this x-axis for a point. So I'm just going to pick this point. It's on the x-axis. And that point is 1, 2, 3, 4, 5, 0. So I just labeled it. But you can pick 1, 0, 2, 0, up to 10, you know, any numbers you want. The y value is 0, the x could be anything. But it's got to be positive for 0 degrees. The x does. All right? So I know what my x value is. I know what my y value is. My r value is always from the origin to the point. So how far is it from the origin to the point? 5. Remember, it's always positive. So if I was over here at 180 and picked negative 4, 0, x is negative 4, y is 0, but the r is positive 4. Because the r is always positive, no matter where you're at. So then I just do my 6 trig functions, all right? My sine, remember, is opposite. So opposite or sine goes with the y over the r, right? Thinking about the alphabetical order stuff. What's my y value? 0. What's my r value? 5. So you just put 0 over 5, which is 0, right? So cosecant, it's reciprocal. Oops, another C. is the reciprocal of that. What's that answer? No. No. Say it again.
Calculation.
Calculation fails, right? Undefined. All right, so it's undefined. You can't divide by 0, right? Cosine of theta. Remember, C comes before S in the alphabet, so X comes before Y, right? What's my X value? What's my R value? So the answer is 1. Secant is also 5/5. You follow me? You can't draw a picture of a triangle for these. You're just on, and I just made up the point, the 5-0. I just knew it was somewhere on this x-axis, positive side, because 0 degrees is over here. If they gave me 90, I'd pick a point on this. If they gave me 180 or pi, I'd pick a point over here. You follow what I'm doing? Okay? And then again, tangent and cotangent. All right? Tangent was y over x. Okay? Opposite side is always the y, adjacent side is always the x. So my y value is 0. My x value is 5. 0 divided by anything, 0. Cotangent is a reciprocal. So this would be 5/0, which again is what? Undefined. So you're going to get a couple undefined. That's okay. For the quadrantal angles. Well, the R is always the distance from the origin to the point. The distance from the origin to the point. Okay? From the origin to the point. Okay, so if it's on the line, you know, X or Y axis, yes, the X value or the Y value, depending on which one you're at. And it's always what type of number? R. Positive. No matter where you're at. Even though your common sense says, well, it's supposed to be negative because, you know, it's I'm at 0, -5 or whatever. But the R value will be positive. The Y value will be negative, but the R value is positive. Okay? So those are ones that get a little confusing if you're not focused, paying attention. All right? Just a reminder again. We do not have these buttons on our calculator. Every now and then we get to use our calculator. Okay? If we've got to find cosecant, secant, or cotangent using our calculator, we're going to hit 1 divided by the sign for cosecant because they're reciprocals. 1 divided by the cosine for secant. 1 divided by the tangent for cotangent. Okay? But most of the time we don't use the calculator unless it's a word problem. We're doing this type of problem, we want the exact values. So simplest fraction form, simplest radical form. That's basically it, I think. Yeah. I used to have to memorize it. If you want to memorize that, you can go ahead. Those are all the quadrantal angles. But you don't have to. All right? Just do it with your picture. I think the pictures are easy. All right? There's your homework. Simple, right? Easy. You can do it. Right, Connor?
Yep. What's this one? No, it happens.
I know, I do it too.